Hello, beautiful people, and future me. So let's do another practice. Okay, what I do? This is complete. This is complete. C sharp. All right then. A lot of typos. Okay, how we are doing? A lot of mistakes. That is 9%, 40. Okay, we try to keep this down. That's the single mistake? No, there's more. 1%, that's awesome. This is awesome. Even my BPM is higher. So what I did differently now is kind of I was holding the word I'm typing in my head, if that makes sense. Okay, so here's one and here's second typo. That is awesome. That is awesome. We got even higher BPM. So good. So good. Okay. So I wanna go over the execute program. I'll not choose randomly. Yes, already. Maybe I can share it on CodeBuddies. Let's see if that kills my CPU. Well, it definitely does something to my CPU. You have one lesson available. Finish it, don't look more. Okay, good. So we are doing this. Text not null, so this is error. Selecting a column that doesn't exist is an error. Try select an email. Okay. Select email from users. Okay. Now select star from cats. Text, name text, integer. Okay, so we have just one with name of Fluff and age of 3, like so. Yep. Here's a summary of this lesson. Create a cats table with a text name column. Then insert cat Kinu into the table and select Kinu back out. Okay, free command. Create cats and name type of text. That will be it. Now we will insert into cats name values of Kinu. Should be it, and then we will select it. Select from cats, and that should be it. No? Near cats. Okay, near cats. Create table. I forgot the table. Okay. If multiple rows match a where clause, they will all be deleted. Delete all the people named Amir or Betty. Okay. So delete users where name equals Amir or name equals Betty, like so, and that is correct. Use multi-row insert statement to insert two cats, Mr. Fluff and Kinu. Can do that, maybe. Insert into cats, name, values, and it will be name. No, it will be Fluff and Kinu, like so, and I'm not sure. They are separated by comma, or how does it work? They are separated by comma. Okay. So we are separated by comma, and that should be it. Now what? Create table users, email text. We have a Amir example, Betty, J, delete from users. And then select something, so we get nothing. Because everything has been deleted. Create table users. Text. Insert into, that returns empty. Result. Create table users, also returns empty, I think. Select star from users, so we have a Alex example, but this one should be unique, and it's not, so it will throw error. Create cats table with two columns, name and owner name, and uniqueness constraint to ensure that the owner's cat. Okay, I'm never able to pass this one, and I'm not sure what I'm doing badly. So we do create a name that will be text, let's say, all owner name text as well. Unique should be name and owner name. And that should be the thing. There we go. Now it will fail. Yes. I mean, I have no idea why. This should be it. Maybe they forgot attached this guy and it's there already. I don't know. Can I email them? Send feedback. Hello. rectangles with width will be real and height real as well. Something else. Create with 2 columns width and height, both of real. Should be it. And it is. So now what? Create table users, name text. We have Amir and Betty, and we will be selecting both of them. So it will return Amir and Betty. Like so. And create a cats table. Text not null, integer not null, vaccinated, defaults to 0. Okay, so create table cats, and it will have a name, text not null, and vaccinated, and that will be integer not null, default 0, like so. Dang it. Oh my god. Too bad I cannot fix it anymore. Text integer default. Select star from user, so it will have a name that will be equal Amir, and then we will have a login count, and that will be 0, the default value. Okay, what do we have next? Create table users, name text, login count, integer, Amir1, that would be the same thing almost. So it will name Amir and double check. Create users, yes, we are inserting it Amir with login count 1, and then we will select name. Second chance, 4 questions, so I will fail 1, I'm sure. Create cats with a text, insert Kino in the table, select backed out. Okay, 3 statements. Okay, so create table cats, and it will have a name text column, and that's it. Okay. Then we have an insert into cats name values will be Kino. Okay. And then we have selecting it. Select from cats. So create cats with text name column, text name column, then insert Kino in it. I'll use Kino, and then select bag. That should work, and it does. Okay, cool. What was the mistake I was doing there? So name text. Create table. I missed the table keyword. Okay. So create cats table with 2 columns, name and owner name. Yeah, this one. Okay, so I'm suspecting it's like this one is expected to be after that. So I will create table cats. Cats, yes. With name, owner, name, unique, name, owner, name. So cats with 2 columns, name and owner name. We have a unique constraint to ensure that an owner's cats can't have 2 cats with the same name. It should be it. And I will not write this guy. That's the thing. I think it's broken. Maybe not. Okay. Okay. Now we are creating cats. Cats. With a name, text, not no, and what's it painted, which will be integer, not no. We found 0. Good. I still don't know the unique. Maybe I'm doing mistakes somewhere, somehow. Cool, I have another lesson, so I can do this. We try to insert a column that doesn't exist. The database system will error. Exit create table users. Insert. Okay, so that will not pass. Any operation on a column that doesn't exist will cause an error. It doesn't matter whether it's select and insert, update, delete, or none of the other less common operations. Select age from users. We don't have one. Update users age. Finish lesson. Okay. That was quick. Dropping tables and columns. Okay. Sometimes an entire is no longer needed. We could delete all data in it, but the table still exists over time. We end up with many unset empty tables in our database. It's better to complete this with the table. Remove tables by dropping them. If we drop a table, trying to access it in any way is an error because it's no longer it doesn't no longer. Okay, so error. Drop cats table. Okay, drop table cats. Okay, here's the result. What's the difference between deleting and dropping? Deleting is always about data, it removes rows. Dropping is always about database structure, it removes tables in most database systems because of drop single column from a table. Later in this course, we'll see examples of dropping other structures as well. Okay, so we can finish, apparently. Short and sweet, short and sweet. Primary keys. Suppose that we have a table with two different people named Amir. That will make it difficult to find a specific Amir. I'm sure it will. So we have that, and it will return name Amir. Amir again, like so. This puts us in a difficult situation as application developers. For example, how do we create user profile pages for these users? We can have two different users profiles at users Amir. That doesn't make sense. Yep. To solve this, most databases have numerical IDs. With IDs, one Amir is person 1 and the other is person 2. Exactly. Table. People. ID integer not null, name text null. So creating that one and that one, where ID is 1, so that will be ID will be 1, and then we have a name, and that will say Amir. Hello Amir. Now, our code can't thread. How do you say that?
Treat.
Now our code can treat the emirs differently. On our side, each emir can have their own profile page at users 1 and the other at users 2. Most real-world tables have an integer ID because it makes referencing rows easy. But manually assign those ID is tedious. And what would happen if we accidentally assign two users the same ID, huh? Then we'd have the same problem that we started with. No way to distinguish between users with the same ID. It's much better to let the database choose ID for us. In SQLite, we can do that by making the ID column a primary key. Okay. In databases, key means a column or set of columns that is always unique. We already seen keys in the form of uniqueness constraints. If we put a uniqueness constraint on one column, that makes it a key. If the constraint requires two columns together to be unique, then those two columns together are a key. Database systems themselves don't usually care about keys. They are more useful for humans as shorthand for a set of columns that's always unique. However, databases do care very much about primary keys. The primary key is a key that we've declared to be special. It's the main primary key for the table. In most real-world databases, the primary key is an integer column often named ID. When we tell the database that column is the primary key, it does several things. First, the primary key column is automatically unique. Okay, good. And we set it primary, maybe? I don't know. Well, primary key. So it can never have duplicate values. Second, in most databases, the primary key is also not null. This isn't true in SQLite, but let's ignore that for a moment. If we create a primary key column, then we won't be allowed to insert duplicates. Okay, so integer primary key, and we have that, so it will say ID1 and name will be Amir, like so, and this will result in error. Unfortunately, primary keys are nullable in SQLite. There's an interesting story behind that, and it reiterates why ideas like nullability matter. An early version of SQLite had a bug that made primary keys nullable. SQLite has a strict backwards compatibility policy, so it still maintains backwards compatibility with that bug. This is exactly the kind of problem we can have when we forget not null. Omitting not null might forever burden us with invalid nulls in our database. We'll have to maintain backwards compatibility with our earlier mistakes to protect those nulls forever. When the SQLite authors forgot to make primary key imply not null, they burdened themselves in a similar way. Now they have to maintain backwards compatibility with that bug forever. Poor guys. Let's see the primary key nullability in action. We'll create a table with the primary key on a name text field. Unfortunately, SQLite will allow the primary key to be null. Okay, so people name. Okay, so that will select. Oh, like so. Create a table with the primary key on a name text field to avoid a problem. Just make it not null. Create table. People, and it will have name text primary key and not null. That should be enough. Most primary keys are auto-incrementing integer IDs. Auto-incrementing means that each new ID increases by 1 automatically. When we insert a record, we don't have to specify the ID. The first record inserted will get an ID of 1. After that, the database will always automatically choose the next unused integer. It's kind of like default value, except it automatically changes with the new record. Okay, so the next unused. So let's say I have 1, 2, 3, and then I delete 2. The next insert will be 2. I think so. The exact syntax for this varies depending on the database. Other databases might require us to explicitly say that the column auto-increments. In SQLite, an integer primary key column will auto-increment. Require us to explicitly say that the column auto-increments. Okay, here is this enough. So integer primary key not null, good, name text, and insert into name Amir. So this will give us ID of value 1, and then we will have a name of what we inserted, and that is Amir, like so. Create a table. People, integer key. No, Amir birthday. Oh really? Do you want me? Okay. So ID 1 and name. The first one is Amir, and then we will have Betty. ID 2 and name will be Betty, like so. I still have a few things to go. Okay, 36. Let's complete this. Auto-incrementing integer primary keys are why you see many URLs like users blah blah blah. When you see that URL, you can guess that users have auto-incrementing primary key ID. The user at user7 blah 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 was probably the blah 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 user to register. You can guess how many users exist by creating an account and looking at the numeric ID in your profile page. URL. We saw earlier that SQLite allows nulls in primary keys for backwards compatibility. However, SQLite will try to help us avoid the problem for integer primary key columns. If we try to insert a null, SQLite will ignore the null and insert the next value in the ID sequence instead. For example, if the highest assigned ID is 1001, and then our null will be replaced with 1002. Okay. So create table, and this one is integer primary key. So this one will have the it does the auto increment, right? So it will ignore our value? Probably. So let's try that. ID value of 1 and the name of Amir. Who is this Amir guy? No? Okay. This works. Huh. Okay. So then we will have a ID 2001 name Amir, and then I suppose we will have ID of 1 and name Amir as well. No? So we imply this. Oh, you guys. This is not how it works, right? Cannot be. The next available. So it goes at the back of the database. Take the highest number and then plus one on it. Alright, it is what it is. Whatever. One last detail about primary keys. A table can have only one primary key. If we try to create two primary keys, in the same column, the database will error. This one is okay then. And this one is error. Primary keys in a nutshell. Each table can only have one primary key. Yes, sir. Primary key values must be unique. Yes, sir. That is kind of implied, right? I don't have to write the unique modifier. Primary keys primary key values can't be null, but SQL will allow null in some situations for backwards compatibility. Grab. Primary key columns can have any type, but most are automatically incrementing integers starting at 1. In SQLite, an integer primary key will automatically increment. Primary keys combine a lot of complicated ideas, but using them is relatively simple. Except in rare situations, your tables should always have auto-incrementing integer primary key. You never need to include it in your inserts. The database will do it for you. Just by typing integer primary key, you get an easy-to-use, automatically managed ID column. Automagic. Okay, so we finished the lesson. We have more available. This one, that one. So we have more to do, but we are on a 41 minute. So that means we are done. And done, please remember, it's always better than perfect.